Good morning, guys. So as you know, we will have homework 2 deadline this Friday, right? Do you guys have any questions? Yeah, I only got from Cook, so which one were you referring to? The first one, yeah? So you'll be creating employee departments, works in independent. Oh. I missed the managers, is that what you're saying? No. Policy? Oh, no. Remember, because it's a weekend thing. Oh. And also for this, they can actually be. So if you have any question for homework 2, come to my office hour today or go to the TA tomorrow. I would expect one question popping out, I'm not sure. So for like the SQL parts as well, you actually have to give me the screenshot of the output. So just make sure you can do it. Do on Friday. So what we will do today, actually I think I won't use this for now. We'll keep working on the rest of the queries that we had from last night. So we finished that and introduce one more operator that we didn't talk about before for relational algebra. Then we'll get into relational calculus today. So as last time, I'll write down the schema first. You can think about query 7 first. Find the names of sellers who have reserved at least 2 votes. Any thoughts? Remember last time I forgot which query, but we were thinking about find the sellers' names who have reserved at least 1 vote. This time we want to see at least 2 votes. What do you think would be a good approach to start? No clue? Yeah.
So, couldn't we join reserves to reserves with this idea being what we're joining and then take every row where the first row I think is equal to the second?
Equal or it's not equal?
Just not equal.
Yeah. Go ahead, maybe. Reserves. Okay, so you say.
Do like a row to one of the BIDs, BID 1 and BID 2.
Let's see, so we do a join. Do you have to put any condition? We don't do natural join, right? Because if it's natural join, it will compare every fields that are the same name.
Right, we just want SID.
SID, so you are saying, if it's equal join, then we just put, this is the equi-join, right? Just compare SID. Then?
Then we want to rename the second column to BID 1 and the fifth to BID 2.
Good. Let me see. So we have. So after this part, we actually get SID, BID, okay? And we don't repeat Do we repeat?
No.
No.
Oh, so then it'd be the fourth. The
Yeah.
second one.
So then another BID, another day. So you're saying you want to rename the second to be BID 1 and the fourth to be BID 2, right? So how do we do renaming the fields?
Like 2 arrow.
We put it right after the tuple variable. So we say 2 becomes BID 1, 4 becomes BID 2. Okay, so now we got that. Then what?
We select where big 1's not equal to big 2, and then we project the name. Or I guess we'd have to join the cells and project the name.
Yeah, okay. So now we have this. So this part changed to BID 1. This part changed to BID 2, right? So we want to select those rows where BID 1 not equal to BID 2 from 10. Okay, and in order to get the sailor's information, what do we need to do? We need to join it with the sailor's relation. Finally, project name. Awesome. Okay. Yeah, actually, I have another approach, but I think yours is better. So, the textbook actually suggested we replace here with cross product. And then you still need to do those, like SIDs are the same, PIDs are different. So yours is more efficient. I'm pretty up. Any question for this one? Can you guys see why we can get the sailors that reserve different, at least 2 rows? Yeah, so here's the most important part right here. And this is the first time when we are practicing, we actually renamed the fields. Last time we only just give the relational algebra expression tuple variable. We didn't rename the fields. Okay, so that's for query 7. Let's get into query 8. For query 8, we want to find the SIDs of sellers with age over 20 who have not reserved the variable. Any thoughts on this one? How we can start? Whenever we think about who have not done what do you think will be an easier way to begin? You want to try subtraction, which is like we take the difference, right? Set difference. So instead of finding who have not reserved a red bow, how about let's start with finding who have reserved a red bow first. Okay. And another criteria here we are having is to think to consider only those sailors who are over 20 years old. So we can also start from there. Let's say, I don't really have good tuple variable names here, but bear with me. So if you want to select sailors who are older than 20 years old, what do you do? What operator do you use? Selection. And the criteria will be age greater than 20. I guess when you say over 20, it's not equal. I don't know, whatever you want. I omit the equal. Okay. So that's it for now. Leave a space here, we might come back to that. Okay. Second thing we want to do, we want to find the sellers who have reserved votes. And later we just take it out. And before we start, let's take a look. Because in the end, we only care about SIDs. Do you think we can do some projection here? Make it a bit cleaner? Let's just take out this. Okay. So what should we do? How can we do to take those SID who have reserved red votes? Let's say Chem 2, store such information. How can you get those that reserve a red vote? So we want to start with those that are already greater than 20 years old, older than 20 years old. Okay. So instead of putting the seller information, we put temp 1 this time, which is here, sellers that are older than 20 years old. Then what should we do? How do we proceed from here to get those that have reserved red votes? From here, how can we?
Selection.
So right here, do we have any reservation or vote information? So what should we do? From here, how do we get, okay, let's say reservation information. Who should we join with? Yeah. So as you can see, for temp 1, the schema, we only have SID. When we join it with reserves, now we have SID, EID, and day. But remember, we want to get those who have reserved those, so we're actually lacking the color information, which is from the vote, so we should join it with those. Okay, so far so good, but we only want those that reserve the red votes. So we should
Selection.
select on what?
Color.
Select those whose color is red. So as you can see now, the whole thing schema is actually long all the way up to here. We also have name and color. But let's say our goal is to have here storing just the SIDs of those sellers greater than 20 years old and who has also reserved red votes.
It's another projection.
Projection. Okay. Running out of space, but here, let's add a projection. So let's rethink again while we're doing this. For this part, we're taking those sellers who are greater than 20 years old. Okay? And we keep the SID information. And for this one, we are saying we want the sellers who are not only greater than 20 years old, but who have also reserved the vote. That is red. Correct? So, go back to our goal. Our goal is to find the SIDs of sellers with age over 20 who have not reserved the votes. So here's where we want to take the set difference. And note right here, we are taking projection. It's because set difference require both relations to be what? Same schema, union compatible. Okay. So let me write the result. The final answer will be for all of the are older than 10 years old, take a set difference on those who are not only 10 years old, but older than 10 years old, but also reserved for red vote. So that's the answer. Anyone still need the left part? Okay, let's get into query 9. Okay, so query 9, we want to find the names of sailors who have reserved old votes. What is the keyword you see here that makes this kind of new compared to the previous 8 ones? We haven't used one operator. We haven't used division. And which keyword will imply division? All votes, okay? So whenever you see all, think about you want to use division. Whatever that implies, but when you see all, you want to take division. Okay? So let's recall division a little bit. Remember we are saying when A is divided by B, to use division, we are assuming A has 2 fields. If we say X and Y, and one of the fields will be in B. We have one field. Let's say Y. So if we're taking division A divided by B, with this schema, what does the result mean? Remember?
Get all the you get the values of x's which are associated with every value.
The answer of A divided by B will give us the x's that are associated with all the possible y values. Correct? So now if we want to use this concept in query 9, what will A be? Which table? We want to find sailors who have reserved all votes. Reserves. Reserve divided by votes. Okay. Let's replace it saying we want reserves. Let's ignore the fact that in the end we want the sailor name. So because we want to follow the formula where this one has 2 fields, this one has 1 field, what are the fields in reserves you will want to keep? What would the X be? X be SID and Y be. So for both, we also just keep the ID. Okay. So in order to get just these columns, we need to do what? Projection. So on reserves, we first do SID and BID. And on boats, keep. All right. So if we simply write down this, what do we have? Yeah. So if you only look at this part, what's the schema for this result so far? How many fields do we have? Only one, and that is? We only have SID. But the goal in the end is to get sailors' names. So we have to associate with the sailors' table by using which operator? And because we want to finally get the sailor's name, check on the sailor's name. That's for query 9. Any question for this one? That's how you would use division. Almost done. We're going to get the query 10. What do you think for query 10? Query 10, we want to find the names of sailors who have reserved all boats co-interlinked. So this reminds me of one of the queries we did, the first one actually. I remember Kwok was saying we could use division. Remember the first query we were just saying, find the sailors who have reserved boat with BID 103. You remember that one? And we were, at that time we didn't use division at all. Why is that? Let's recall that real quick. Find sailors who have reserved boats. I remember at the time we only did, okay, let's just say we used the SID, even though I think we used name, but let's use SID. So remember we take a reserves, and you just simply have to select the BID, where it's 103, and we just put. At that time, we didn't use division at all. Why is that? Yeah. Because what? Because this is unique. Okay? Because this is unique, so there's no such problem as saying find where it reserves all of the boats that have ID 103. But here is different. 10, for question 10, we change this. Find sailors who have reserved boats with BID equal to 103 into reserved boats with name equal to interlake. But because the name of the boats is not unique, okay? So there might be multiple boats with the same name. And we want to find those sailors who have reserved all of the boats that are co-interlinked. So that's why for this one we will actually need to use division, but not for the query one. Okay, so we're going to use division again. How do we start? If you decompose this query, what do you first see?
Selection.
Selection of boats.
Name.
So we want to select on the boats where
Name is
name is interlaked. Let's store this just in temp one. Okay. And because later on, this will be the part that's, what's it called, denominator or denominator? Okay, A divided by B, B is denominator, okay. If we want to directly use it as the denominator, what should the schema be? Right now we have, so far we still have BID, the name and color. But if we want to use it as the denominator in division, only have one field.
BID.
So we should do extra step right here, which is projection BID. then this is ready to be the denominator. Then what will the denominator be? Numerator? Numerator. Okay. What will the numerator be? Reserves. Yeah, really bad with those names. All right, so if reserves, we want to make it the numerator. What are the fields?
SID and BID.
SID and BID, so we should do
Projection.
And because here we actually prepare it to have only one field, so it's ready to be on the denominator. Okay. So how's the schema for this so far?
SID.
Only SID. And what does those SID mean? Sellers SID who have reserved all those co-entries. Correct? But what's our final goal?
Names.
Get the names, because we want to get a seller name. So what other information should we associate it with? Join sellers, and then projection on the name. Okay. So that's for the 10 queries. Any question? As long as you as long as you understand all these 10, I think you should be good for relational algebra. 90%, because then we have another operator. Okay? I'll give you a few more seconds, or you all got that. I'll put the screen down. So that was for the 10 queries that we practice on the, I think, 9 relational algebra operators that we have learned. Those are the ones included in the textbook. But actually, there's another one pretty important that I want to talk about today, which will take care of the idea of aggregation and grouping. What I mean by aggregation and grouping is that, so in addition to retrieve data, some computation is often needed. If you think about the 10 queries that we have worked on, actually there was no computation included. Right? We were just retrieving data based on different criteria and what are the fields we want, how do we join tables together. But there was no computation involved at all. For example, counting, or we wanted to find the average, or we want to find the sum. So none of that was included. So right here you can see concepts we will want to use frequently will be maybe we want the maximum, maybe we want the minimum on a column in a field, or the summation, count, or average. For example, how many sellers reserve blue books? Do you think by what we have just learned, the 9 operators, we can achieve this? We can achieve all the sellers who have reserved blue books, but we are not able to do the counting just yet. Okay? Another one is find the average age of all sellers. We can get all the age of all the sellers, but now, based on things we have learned, we're not able to do the average yet. The third example will be to find the highest rating of sellers younger than 20 years old. Right now, we can get all of the rating of sellers who are younger than 20 years old, but not taking the maximum of those just yet. Okay? So what we will need to do, besides that, sometimes we want to do some grouping. For example, if we have some fields that we want to group the sellers by, for example, we want to find the average age of sellers in each rating level. We have different kind of rating. If we want to group the sellers first, for example, though we want to group them into this group are the sellers who have rating equal to 1, this group rating equal to 2, and then we take the average age in each group. Another example would be to find the highest rating of sellers at each age group. Then we just swap the order. We group by the age first, and then find the highest rating. So these are the concepts that we want to achieve, besides the 9 operators we have learned so far. So this is where we want to use alpha operator. So there are 2 formats, or you can see 2 formulas of alpha operators. The first one is the one I said earlier. We just simply do some sort of computation among all of the values, maybe in a column or a whole table. For example, okay, not yet, not for example. Okay, so that's the formula for that. We will put alpha and subscript, we put 1 argument, and we put r as the input. So for the argument 1, we call it the aggregation function. Okay, so right there you can say I want to take the average, I want to take the maximum on what? And r is just simply the relation you want to work on. So if we have this, let's think about how we would do to find the average age of all sellers. To start with the easy part, what will the r be? If we want to find the average age of sellers, what do you think the input relation will be? Just the seller. And what would the aggregation function be then? Without thinking how you will write it, but what's the concept of that? Average of the age, okay? So this is how we will write it. So we just simply put alpha, and on the subscript we say we want to take the average of age on Taylor's relation. Yes, that's how we can do the first example for alpha operator. Let's think about the second one then. I'll let you try it. How would you find the number of sellers who have reserved blue votes? Let's say, very simply, if you want to find the number of sellers, we do counting. And which field will you count? SID, because it's unique, so you don't want to count S name, right? Because there might be duplicates, so we count SID. Let's say we do count, then we can get a number of sellers. Then what would the input relation be then? We want the sellers who have reserved blue votes. How many relations will be involved? 2? Which 2? Why not seller?
We don't need the name.
We don't need a name, and we are counting SID, and that's already in reserves. Okay, that's right. So we will have reserves and votes. We need those 2. And what do we do with them? Do a join between them, right? How do we get blue votes? Selection. Okay, so the answer should look like this. We take a join, natural join, between reserves and votes. Take the selection of the color, which is blue. Finally, we just say we want to count the SIDs. Question for this one? Okay. Then I'll move on to the second type of the alpha operator. So the second type, this time we actually take 2 arguments instead of just 1. When I first learned this, I think it was kind of confusing, but then later on I thought it makes sense. So this time, for argument 1, instead of doing the aggregation function, we do grouping first. Then argument 2 is the aggregation function. All right. So why do you think we'll be in this order? Because if it's based on the first type of alpha operator, wouldn't it be nicer if we just keep argument 1 as the same purpose? and then the one added, do the grouping. Any thoughts why the order is like this? Yeah.
Because the grouping is done first before the aggregation stage.
Exactly, because when you think of the process, you actually do the grouping first, and then you apply the aggregation function on each group. So, yep, that's right. So we want to put the grouping as the first argument, and then aggregation function. Normally, the way we do for grouping is just saying you put the field name that you want to group by. That would be it. So think about how we would do for each rating in sailors, find the oldest age. Well, I mean, like, you group by rating first, and then find the oldest age among each group. How would you do it? What would the first argument be? Rating? Yeah, right? Because we want to group by rating, so you will first say alpha, and the first argument will be rating. So then we group the sailors by ratings first. And what would you do to find the oldest age among each group? Maximum, max 8, yeah. So that's it. Okay. First argument, we group by rating, and then after this part, they are broken down into groups. Then we find the maximum age among each group. And the relation is simple, just say. Let's try the next one. So for each color, we want to find the number of boats. What would you do for the first argument? The first argument we put color, group by color, and then just simply count. And also here, always be careful, you want to count the primary key. So that's for the second type of alpha operator. So I think in homework 2, you will be using alpha operator. I think I put that, I forgot which question, but I was asking for employees in departments or something, you want to group them first, and then find average or something. So that's where you will use alpha, okay? Just remember, for the second type of alpha operator, the first argument you put is grouping, the second one is whatever aggregation function you want to use. So that's for that. And for alpha operators, let's think about when we think of them in tables, like input as tables, output as tables, what would they look like? Let's try out the 4 examples we have worked on. So, I used the data that we've been using for the 10 queries. So for the first one, it's very simple, right? We take the average age among all sellers, and this is how the result should be. Just one field, one row. Okay, and you can see the field name, actually, you just really simply rename it as average age. Okay, so this is what it should be. How about the second one? I put down the intermediate part. I put down the part until selection. So what do you think will be the end result? So the part this table right here, is actually equal to just this part until here. So what do you think will happen after we apply count SNT?
One column.
One column,
The number of
so that's it. So then the end result also will just be one row, right there. So as you can notice, the first 2 examples, we only have one value for each. That's because we don't do grouping. So we just do an aggregation over all of the rows. So that's why we only get one value in the end. Let's think about the third example we did earlier, where we said we want to find the average age of sellers. No, we want to find, for each rating, sellers find the oldest age. So as you can see, we first did the grouping, right? And that's how the number of rows will be generated, based on how many unique ratings there are in our data, and then in the end, we just find the maximum age among each group. So as you can see, for this result, we get the number of rows is based on the number of unique values in the first grouping one, like number of groups, right? And then the number of fields is always 2, because the first one will indicate what's the grouping based on, the second one is the value. So that's for this age, a maximum age. So for the fourth example, I did the same. I gave you the intermediate part first, and then you want to think about what's the end result. So until here, I did the grouping. Okay? I did the grouping based on color. So we have 3 groups right now. The first one is red, second one is blue, third one is green. And we want to count the number of votes in each group. So what do you think the final result would look like?
The 2 columns,
2 columns, and the first column will be
the color,
the color, and the second will be
the column,
count the ID. And how many rows will we have? 3. Yeah, so this is how it should look like. Oops. Okay, so we get 3 unique colors, red, blue, and green. And red we have 2 votes. Right here, blue we only have 1, green we also just have 1. That's how the result should be. So even when you think about doing aggregation without grouping, you would just think about a value as a result, but the result is actually still a table. Later in this semester, we will work on the aggregation on SQL commands, and you will see that when it returns, it's still a table. All right, so until here, we finished all of the relational algebra. And in the rest of today, in next lecture, I'll quickly talk about another concept called relational calculus. Okay, more focus, more emphasis, let's say on midterm. More emphasis will be on relational algebra. But relational calculus, I think you guys would think it's familiar because we used that before. You have seen it before. So let's talk about relational calculus. Remember at the very beginning of this chapter, we were saying there are 2 ways of presenting relational model. One is relational algebra, another one is relational calculus, correct? And for relational algebra, we were saying it's basically expressing how the queries will be done, so how we do it. But for relational calculus, instead of saying how we will do it, we're just saying how the results will be like. So instead of being procedural, this is declarative. So there are 2 variants of relational calculus. The first one is basically take on tuples as values. So it's called TRC. What do you think the T will be like? Will be what the T stands for? Take on tuples as values. The T is tuple. Okay, just tuple relational calculus. Because I haven't put these blanks for a while, so I was just like I want to do it based on whatever keywords. The second one is domain. Okay, so we have 2 types of relational calculus. The first one is tuple relational calculus, which take on tuples as the values. The second one will be domain relational calculus. We call it DRC. The variables range over field values. So more emphasis will be put on tuple relational calculus. Let me see. All right, so for tuple relational calculus, we have seen this before, right? We have been doing this since the beginning of the semester. We kept doing in a set. We have these tuples that satisfy the criteria. So this format keeps occurring, but we never really talk in details about it. So a tuple relational calculus query will have this form where the T we call the tuple variable. I used to call them like the nickname for the relation or whatsoever. So this time we call it the tuple variable. And for P, it's actually a formula that describes T. So for this kind of form, the output will be the set of all tuples on T for which the formula PT evaluates to be true. Okay, so let's think about how we should, what we will write down in terms of tuple relational calculus. For this example, we want to find all sellers with a rating above 7. What would you do? This is a bit tricky because we want to, well, I think conventionally they always rename it. So in relational algebra, we just use Sailors, right? Use the name Sailors. And let's say we want to use them as S this time. If we put S as the tuple variable, what do you think will go on the right-hand side?
S dot rating is greater than 7.
Yeah. Exactly. So this is like a bit trickier. So you want to say S is in Sailor. So S we denote as tuple, okay? And this is the in symbol. So for S in Sailors, and the tuple's rating will be greater than 7. So that's how we will write it for tuple relational calculus. So before, next time we will work on different examples, also mapping to the 10 queries we did for relational algebra. But before we do that, this time I'll just quickly talk about some of the very basic backgrounds for TRC, tuple relational calculus. So for the notations, these are notations that will be easier when I talk about here. So if we use REL, we are just saying it's the relation name. If we use R and S, we're very familiar with them. They're just the tuple variables, which are the relations. A, we say it will be the attribute from R. B, attribute from S. And operators can be anything from here. Okay? So for the TRC, we have the most basic building blocks for it. We call it the atomic formula. So as you see earlier, we have S in Sailors, right? So here we're just saying R in REL. And also we can say the attribute in R having an operator with attribute in S. And instead of comparing between two attributes, we can also compare between an attribute and a constant. So that's the most basic building blocks for TRC. And based on these atomic formula, we can just combine them however we want. Okay? So on the right-hand side, when we talk about the criteria that the tuples should satisfy, you can combine them however. Right? You can either be just any atomic formula, or you can use it like this. Okay? It's either P and Q, P or Q, or P so that Q. Right? And here, this means exist, and this means for all. Okay. So these are just what you will write on the right-hand side for the TRC. Okay. Easy. So that's it for today. So I just want to remind you, don't forget to turn in your homework 2 this Friday, and review session next Monday in class. Also midterm, in case you don't know, that will be Tuesday evening. Anyone can't make it? Let me know. Yeah. I think, yeah. Because I don't really want to make another exam, so it would be nice if everyone can be there. Just let me know as soon as possible if you really cannot make it. Right? See you on Friday, and don't forget the homework